IoT Unplugged. Tune in to the Internet of Things. In a time of growing gas and oil prices, and amid a backdrop of a warming planet, many people can understand the need to reduce and conserve energy. Environmental, cost, control, the benefits of energy management are endless. Yet what is not as abundantly clear are the strategies and implementation procedures used to get things like buildings, which contribute between 30 to 40% of global carbon emissions, properly enabled. The key is IoT, but what's the way it's implemented?
To discuss this, I'm joined by Matthew Margetts, Director at Smarter Technologies. Matthew, thanks for joining us today. If you can just start by introducing yourself and what Smarter Technologies does.
Sure, Christian, and thank you for this opportunity to talk to you. I'm Matthew Margetts. I'm the Group Head of Sales and Marketing at Smarter Technologies. We are, as the name implies, a company that is a tech company, and we are focused on the manufacture and delivery of monitoring equipment, principally for the built-to-state. And the monitors that we have capture electricity, gas, water, fundamentally utility usage at a property, and we also have humidity, temperature, and air quality sensors. We run them across our own network. We've been doing this for a number of years. Our clients are principally landlords and large companies that have or are interested in environmental and sustainability matters.
Okay, environmental and sustainability, and obviously energy plays a big part of that. So this is going to lead us into our first question, and that is the management of energy. What is energy management in your words?
Okay, so one of the observations I make continually is that people know the cost of their energy. Businesses, 3 or 4 years ago got the sort of habit of saying, okay, this is how much it costs, but no one seems to really understand how they use energy. And what we've started to do and help companies understand is how energy is utilised in their operations. And there's an intensity piece that they need to understand, because actually when you look at the data, when you look at how you're using energy every half hour and across which phases, you can start to understand, we're wasting energy here, we have too much reactive power. So energy management is about not the cost of energy and whether you're switching things off, but actually how you're fundamentally using it, how your operations are tied in, how you pull energy or load at certain times, what your electrical setup is. If you want to get rid of gas, whether can you actually get rid of gas? Have you got enough power on site to actually support your objectives? So energy management is about understanding your utilisation, but at a granular level, and being able to adapt and change that to suit. Equally, it's about being able to introduce renewables and on-site generation capability.
Okay. Well, when we talk about elements of a building's energy usage, I'm wondering what can be managed, so down to the smaller level and down to the higher level. Do you have some examples?
Yes, okay. So first things first, let's just unpack that a bit and say, well, what is a building? Is it a factory? Is it an office block? Is it a retail venue? Because each of them obviously have different preferences. Is it a school? They each have different energy profiles. And if we take your office block as an example, we have all experienced the idea of remote working, and it is now becoming ingrained. So at a simple level, you can see the operation of your business that might have been run by your buildings management system is geared up for everyone arriving at 8:30 and everyone leaving at 5:30, 5 days a week. Now, does that reflect your actual profile of people coming into the office? For example, do you operate half-day working on Fridays? Do you close certain floors? And this is where you can sort of cut areas and remove areas. Equally, in terms of immediate impacts, Office blocks have HVAC, heating and ventilation, air conditioning units. Now, they operate based on an assumption that there are people in rooms. Are people actually using those rooms? Are they coming in? Are they set up to actually come in and operate at the right times? Equally, when I say the right times, you've got people coming into your office at 8 o'clock. Is the idea that the office then starts to heat up at 8, or could you heat it up, or could you heat up certain rooms a couple of hours earlier when you're effectively on your nighttime supply? And you could allow the heat to be retained in the building so that when people come in, you don't actually need to turn up the heat. So there are lots of little things you can do around the fringes that actually have profound effects. So looking at the property type, looking at the operation of the building, how things are set up, when you go on this journey, you start to explore these ideas, you can find ways of reducing consumption and removing it altogether because it is actually redundant.
Okay, well, so as you mentioned, like this optimization of how energy is used, but I was wondering, the current climate we're in, if you could explain why is energy management becoming of increased importance? Obviously, it's going to be of different importance to different people and sectors, but if you could explain why people are starting to really take this optimization of energy a lot more seriously.
Okay, well, I think now, if you've been any form of energy consumer, you've woken up to the fact that the prices have gone up. Wholesale gas, the prices exploded because of the war in Ukraine. Prior to that, we had COVID. It's not so long ago, people have forgotten. I had a lot of calls from businesses saying, but we've been shut for COVID, but our energy bills have not gone down. So they're paying costs. And again, people realise that there is no such thing as cheap energy anymore. There is no such thing as having unlimited supply of energy. If you have, as I do, I speak to hundreds of businesses every week, they are often power constrained. If you have a system where your lights are tripping, it's because you don't have enough power on site. And again, just why is this? Well, think about it. If we're getting rid of gas and people are using sort of electricity as their main feed in terms of their energy requirement, your demand is going up. People have more powerful computers. We have EV chargers being used on sites. A great many offices have EV chargers. Again, that creates a draw on your power capacity. So everyone's kind of got interested in energy, but for reasons to do with actual operation and delivery of services. Equally, alongside that, you cannot really move without having to comply with environmental standards reporting. In all government tenders, in fact, I've looked at, we are a significant supplier into His Majesty's government of services. There is a requirement to answer what your net zero carbon policies are. What is your pathway to net zero? And these documents, which have to be signed off by a member of the board, they have to reflect a journey and a pathway that is seeing a reduction. They are auditable and accountable documents. So that's why energy has become important. People want to show that they're part of it. They recognise it's not a sustainable outlook. If you just consume, you should be managing it without just raw consumption. So these are the reasons, these are the drivers. You've got cost, which is a very big stick, and then you have the carrot, which is if you want to work and you want to use or leverage your sustainability credentials, you need to be able to demonstrate it.
Okay, excellent. And now we talked about what elements energy management can be involved in the property. But now I was wondering, how do you implement an energy management strategy, and what does that involve?
Okay, again, a great question. A simple word is communication. You need to be able to help people understand what they are doing and how they can contribute to reducing carbon emissions. So, as an example, if you have a factory, let's take a printing works. You might have a printing works where you have things being printed, things being cut, things being shaped, And you need to make sure that each of those processes is only working when they are called upon to work and that they're not running idle. So you need to say to people, we're going to switch everything off, because strange to relate, a jig cutter in a print works calls a lot of power while it's waiting to be used. If there are no jobs scheduled for that piece of kit on that day, do not use it. So you need to communicate that, and you need to get across the business an understanding that it's everyone's responsibility to understand how to reduce power usage. Similarly, it is as banal as do not leave your computer on standby overnight. Switch it off, turn it off, shut it down. And again, equally, it's, again, very simple things, such as we had a school where they, doing the right thing, they were allowing the old boys at the school to come back and use the facilities in the evening, which meant that floodlights, particularly in the winter period, were going on, and lights were on and power was being used. But that meant that the school walked straight into the higher billing rates that occur within the winter months. There are 4 days, the triad periods, where if you exceed your capacity, you are paying double. And their costs went up by thousands of pounds during this period. And it was because they just weren't aware of the issues, which meant that they now, because they have been hit with these bills and they understand why the bills came about, they've been able to explain why they are closing the facilities on certain days, or only having half power on, or there are no hot showers after usage. And as long as you can communicate that, people can understand it. It's very difficult for people. I'm thinking principally here with electricity. People do not have a relationship with electricity. You switch the light, it's on. You don't. It ends at the door. What's it all about? So it's hard for people to understand how they're consuming and what that costs. We're getting a lot of metering in place that helps people see it in a monetary value, but it's very difficult to understand. And the more you can communicate with people and help them and give them the tools, which is really what we do, give them the tools to see that profile, they can improve.
Okay, great. A lot of this way that it works, I suppose, is going to be a lot of sensors and the Internet of Things, IoT devices that are communicating this info to say when something can shut off or something can't, or inform a larger system. I was wondering, can you walk us through what kind of monitoring systems are used in energy management in, let's say, a building, a commercial building, and how it interacts with its environment? Are used in energy management in, let's say, a building, a commercial building, and how it interacts with its environment?
No, for sure. So obviously, we manufacture sensors. We help surface this data. So you have an instrument that reads your power consumption, and our sensors surface data on what's going on with each particular phase. But you could have something as simple as a thermometer in a room, which actually tells you the temperature in real time. So we harvest data. Our equipment, our shtick is that we harvest data in real time, and we have a real-time live network that we take it over. But the real-time piece is you can use a thermometer, something as easy as a thermometer, to say, hi, this is the actual temperature in the room. You don't need your system then to take over and run it. I've seen systems, again, there was a project launched by, I think it was Dorset Education County Council for their schools, some of their academy schools, and they realised that a lot of the equipment going in, these were new build academy schools, was quite sophisticated, and that the people on site didn't necessarily know how to use it. So what they actually did was they created a visual interface of the heating and energy drawing equipment in the school, and they allowed every caretaker on site to be able to actually see in a visual, animated way how power was literally being used and reported, so that if there was a fault or a blocker, they could take action. But more importantly, they could look at the classrooms, which would be indicated as red or green if no heat was going in, red if heat was going in. And they could actually say, well, that classroom is actually, it's got a red there, it's actually not being used, let's shut it down. So again, there are the point of all of these monitors and sensors, as you mentioned, is to make life easier. And there is no point drowning people in data unless you can say that spike is the warning, that is the thing you need to take action against, this is what you need to look at. Because otherwise you're just messing up everyone's kind of understanding. They're powerless, they don't know what they should be doing. So you have to you have to surface data, but you have to surface the data in a way that people can use it and make informed decisions as a result of it.
Okay, maybe this is where AI systems come into play, but I was wondering, is there, like, for instance, a level of automation that can be introduced to this thing? So as you mentioned, people, won't be sort of drowning in this data and kind of struggling to extrapolate what to do, that this info could be sent to a central cloud, or where it can then be processed and then actioned throughout the building.
So AI is a phrase, a buzzword. It's logic that says, pattern recognition would determine this, and we would therefore be able to understand. And yes, these models are important, and they act as a backbone. But you need to have that running and the capacity for people to then tweak it at the edges. They have to have the authority, they have to have the administrative authority. But as an example, as we've seen over the last year, the weather in Britain varies greatly. The seasons do not seem to be following each other. And if you are programming everything based on last year in this period, you would be sadly mistaken, and you would waste a lot of money, and you would dump a lot of heat into the market, or you would chill a lot more. So you need to have, yes, you can have systems that run quietly in the background and will process. So you have all of your rooms automatically heated to 21 degrees and shut off. And you then have fail-safes in that you have thermometers that actually record that is the case across the room in certain places. But you should also allow somebody to say, well, actually, we have a lot of people coming in to the facility today. We don't want it at 21 because everyone's going to give off 2 degrees heat because they're going to be there for a couple of hours. In fact, we need to take it quite down to about 16 or something, or 18, so it's not stuffy. So you can have discrete systems that work and take charge, but people, again, need to understand what is happening and what is going on, particularly if you're using intervention technologies such as solar coupled with battery storage. You absolutely want the batteries, which would be programmed based on data, to kick in at certain periods where you've got peak load and you want to shave it. But AI doesn't replace the human, it is a framework to support the human.
Okay, so moving in that vein with regards to data and also the monitoring of data, I was wondering, can you tell me what analytic tools are used in energy management systems? Normally, is it just a feedback of what's being viewed, or? So
as with any system, the data is only as good as the how is it being captured. Good data and good data results. So we harvest directly from the power supply. Others don't necessarily do this; they might scrape data. But you've got a good data pool, and the data is sound. Yes, you can start to look at the patterns intraday, intra-week. Yeah? You can start to introduce other sets of sort of occupancy levels or overtime, and you can start to then forward plan what your consumption requirement is based on jobs coming in, based on what you've seen, and you can actually understand this idea of the concentration of energy. We had a client, and it's on our website, so it's referenced, who was looking at their factory, and they recognised that they had a number of workstations, 1 to 14, and they set everything up in terms of the electricity and the gas extraction and burn and bits and pieces to follow the idea that everything was working in a logical 1, 2, 3, 4, 5. But when they actually looked at the data and looked at their workflow patterns and the types of jobs they were doing, they didn't work 1, 2, 3, 4, 5. They actually did process 1, and then they actually did process 7 and they went somewhere else in between. They went to 14 because that particular job required that particular workflow through the factory. So not everything needed to be turned on to support it. And it's just using and building the data sets, but you have to have a sort of an attitude which is inquiring to say, how could we, or what could we do to shave energy consumption? And what data do I need to make an informed decision? And you build it from there. You take your data in, and then you, as with the data scientist only approach, you would then ask the question of the data to see what results you can get.
Okay, now moving on to energy management in buildings. I was wondering, like, for instance, talking about maybe like a smart building or something where it's heavily connected and there's loads of sensors. I was wondering, is there a variation in the type of these smart buildings that they could, for instance, run on different technology or something like that? So, for instance, like a school might need a less responsive system to be able to tell them all about the outgoings and ingoings, because they're a lot more scheduled when people come in, as opposed to like a residential block of flats where, there's no schedule for when people are going to come and go or turn their lights on or turn their gas on.
Oh yeah, no, absolutely. What I would say though, and again, if we start with your first proposition, a smart building that's sort of heavily wired up. When a building is delivered by a developer through an architect, it has a certain profile. People then move in, and the humans change things. So when you think you have a building that is smart, you can only really say that after X many months of operation, where you've seen people actually living in the place and you've adjusted for it. And also just bear in mind that when clients take delivery of a building, whatever the type of building it is, they will make adjustments to some of the floor plans, where you will put in filing cabinets or you will put in sub-meeting rooms, and that may or may not affect the HVAC profile. But if we branch that out, there are many manufacturers out there who will say, you can lock everything into our system and you have one head end where everything comes in and it's one profile piece, and that is a virtue. But you should also... those sorts of systems should be open source and allow for many monitors to come in, because you can find, as an example, we put vibration sensors in on HVAC systems so that we can see if the thing is rattling, we can tell it's broken. I don't need to wait for it to break. The fact it's vibrating a certain threshold or frequency tells me that there is a mechanical fault that is starting with that machine. I can send a service engineer. Now, that instrumentation can sit on the device and be taken off the device once it's been serviced or whatever's happening. So you can introduce and change things. So the observation is there are many systems and they are all scalable, but depending on what you're doing, you should look to always have the right information for it's truism. You have to have the right sort of information for what you actually want to get out of it. So it's common sense, really. Everything is scalable. You can overspec systems. I mean, the number of times we get people saying, could you do this room? Could you do this set? Yes. It comes at a cost, but in terms of the effect you're able to have on your actual energy consumption, don't think about what is the cost benefit I'm trying to drive here. An analogy I use, I used to do an awful lot of cycling. I used to be a typical mammal, and I remember going into a bike shop and looking to buy a very expensive pair of pedals because they would save me 3 grams, 5 grams in weight, and they were the deluxe pedals for my super bike. And I remember the shopkeeper turning around to me and said, "Sir, you don't need lighter pedals. You need to lose the weight." And it's like, he spends 600. He didn't want to sell me this product because he said it's a waste of time. You're not you're stupid. And I think sometimes you have to take a deep breath and say, okay, where will this take us? Are we better? Would we be better spent looking at our treatment of grey water than trying to understand how this suite of rooms is doing in a hotel, for example. So that's, common sense applies. Instrumentation should be appropriate to what you're trying to do. If you are investing and you have a program, and a lot of factories operate over a period, you do need to constantly look at this stuff and think, what's the shape of my business in 3 years?
Okay, maybe I was wondering if we can perhaps hear a case study, or maybe do you have any examples, where like these sort of smart buildings have used sort of energy management solutions to reduce their consumption or emissions? Let's say a large commercial building.
Yeah, we see it every single day. So there are there are two journeys. Once you wire everything up, and by that I mean the meter, and you understand what's going on with the phases and what's going on with, if it's any sort of restaurant building, what the power factor correction equipment is, you can spot mistakes. So what we see is people move to what I term the efficient frontier. They get to their true energy usage because they realise that they've got woeful power factor correction equipment and they're wasting energy drawing power incorrectly. And in terms of once you've done that exercise, for example, we had some hotel groups who wanted to cut their gas and they wanted to go to convection electricity. Now they had large rambling sites, so in both cases we've been able to understand how the energy is working across the business, across the various sites, and they can therefore reduce redundancy or issues of waste, but they can actually understand how much capacity they've got and where they can introduce heavier electrical load based on what the demand is in the kitchen and or the associated property, because they only have so many kVA that they can play with. So that's where we've got case studies with hotels who've been looking to switch. I alluded to the business, the manufacturing business. I can't put figures on it, but it was substantial, and what they did was they understood how their processes flowed. They cut their gas, they were able to monitor their gas usage. We had a gas monitor. They realised their gas burner was actually operating out of hours on a different cycle to the one they had thought. We have, in many cases, people, because they understand their actual energy costs, because we allow you to enter your actual price per kilowatt hour, they can start to investigate what sort of contracts they're on based on how they actually use energy. Many companies hold excess capacity needlessly. Why? If you don't use it, give it back, because you're now paying a disproportionate amount for it. Equally, if you know what capacity you've got, so we did a factory that had been listed as a manufacturing plant on its SIC code and the understanding of the landlord. When we went to the factory, we found that the business was, totally healthy and doing what it was done. It had just moved its manufacturing a few years earlier to another location and used this particular site as its logistics hub. Its power was a third of the capacity it had on site. The property next door was a bakery who were running shifts based on their available power, and their power kept tripping out because when you start up ovens and bits, they draw 9 times as much load. They'd gone to the distribution company and said, "Can we have more power, please?" and been quoted £90,000. As a consequence of knowing that the building next door to them had 2/3 power capacity in excess, they were able to do a bilateral agreement and pipe the power supplies through, because it was submetered in a different way, and pay accordingly without laying out £90,000. So these things are material in terms of their impact. And there are lots of examples that we have, mainly anecdotal, because people don't tend to want to go public on sharing how much money, where just by knowing how you're using power empowers you to make cost cuts. But offices, you turn off the HVAC units if no one's using it. We have gyms where, again, swimming pools are big chunks of water that need to be heated with gas. Someone turned around and said, The swimming pool is heated to 22 degrees, 21, 22 degrees. Why? Why don't we turn it down to 18? People jump in, they think it's a bit chilly, but then they carry on swimming and they warm up fast enough. There's initial shock, and obviously there's a lot of heat created in swimming pools. But just by doing that, you've taken your gas demand down by 12%. It sounds strange, 21 degrees down to 18. Well, it's about 12%. So as a consequence of that, think of the saving you're making if you reduce your gas bill over a year by 12%.
You mentioned in terms of the bakery how they came up with an agreement with their neighbour to maybe utilise some of their gas. This has got me thinking, like, for instance, if whole cities adopted kind of, smart buildings that had these energy management principles, how would this affect, let's say, that city's energy usage, or even the country as a whole?
But in terms of kilowatt hours, so as an example to illustrate that, and I was talking about electricity in the previous example, but we have a client who has a trading estate. On the trading estate, because again, it's one of those situations where people don't know necessarily what the operations are of all of the tenants, there is a data centre. The data centre generates a lot of heat. They cool with water, because that's the fastest way to dissipate heat. We have tapped the heating supply, so we have the capacity to run hot water over distance to another building, and the temperature coming off would be 22 degrees. Now, if you have to heat your heating in your other building next door, adjacent, within 100 metres, if you've got a third less that you have to heat up on, you are obviously saving money, and you are reducing your carbon appropriately or proportionally. Now then you scale that example up to a city, and absolutely you have effectively a dynamic network where you have heating up networks operating, you have excess capacity being pulled by parties who need it, and you have balance achieved. So yes, they can work. The balancing act is obviously something that needs to be supported by excess capacity, and by that I mean renewables or generation capability on site, because business profiles change, because the weather changes, because of snow days, strike days, or whatever. You need to have a responsive system. So you would have to have a level of excess capacity on the system, but no, it's certainly manageable. But you just need to make sure you understand what your base load is, etc. To your point also about cities, and we've done some work on this, we are being supported by industry, which is kind of coming through with things like smart lighting. So if you think of a high street or your road that you live in, it doesn't necessarily need for every light to be on at full luminescence. You can have 45 degrees on every other light at luminescence, and you can still see someone. And you can also, that will also work with CCTV. You can still see someone's face. It sounds strange. You think, it has to be bright as bright. No, it doesn't necessarily. It can be slightly dimmer. And it's those sorts of things that, again, allow you to shave your energy that would be supportive of a smart city. I mean, I'd love to get involved in one. I've seen tenders for them. The management and the understanding of all the component parts is it's a lot of work, and you'd need to have, again, good data. I don't know where it would be a great fun project to do, but you'd never stop having to learn and build your model. But yes, ultimately they need to happen, and we need these things yesterday.
Okay, well, I was wondering, maybe looking forward to the future, are there any sort of specific building designs that can, or construction practices that can enhance the smart city, the smart buildings, or, energy efficiency of buildings, and how they interact with their energy management systems?
Okay, so obviously I'm not an architect, much less a civil engineer in any shape or form. So I can only really go on what I've seen and what I've heard. Equally, in terms of new build construction, on the residential side, there were calls to have post-Grenfell 2 staircases in every building, and now that has been pushed back for another 3 years, as long as you have certain safety features in place, which are obviously required. No one wants to build anything that's unsafe. So the observation I would make is, having seen some of the stuff in the construction, there are materials such as wood, which over 2 stories, because fire risk at the base, and you can mitigate fire risk, wood could play a bigger part in the construction of homes and offices. You can also look at tent-style strengths of concrete, and again, I saw this wonderful presentation where people are saying, well, you can actually create one super beam, a bonded beam. So I think the material science in wood, as an example, where you have layers, instead of one giant trunk, which doesn't exist, you have sort of slatted and glued and compressed. You can get you're at 30% of the weight of a steel girder, but with the same tent style strength. So I think wood and materials, obviously renewable, mean that the carbon, the legacy, the carbon load in creating the building, is the carbon debt is reduced. And my understanding is that equally within the cement industry, they have made strides in terms of some of the properties of the materials used. So I think you see better materials, more informed decisions, and a recognition of how people actually live. I mean, again, it sounds daft, but does every house need a bathroom? If we're going to have heat networks, certainly we don't need boiler cupboards. There are these sorts of things that are kind of coming in depending on your location. So I would say that there has to be some thought towards design, and then these things naturally then feed into the sort of envelope of buildings. I think there's a site up near Manchester where they kind of build houses. I think Bovis have one. They sort of play around, but I mean, ultimately, buildings have to be able to demonstrate a low carbon footprint in their construction and the embodied carbon that is created, and then in their operation, they need to be attuned and accountable for how much energy they are using. And I think if you look at some of the properties, I'll just quote London as an example, there are some tower blocks where the energy profile of those buildings is such that they take a lot, they burn a lot of power to work. So, I mean, that's all I've got on that subject.
Okay. Well, looking forward to sort of future trends and challenges in smart energy management for buildings, what do you think they are from like a technical and even a policy perspective?
Okay, so I would say the first thing is education, and by that I mean understanding how you use energy in your operation, and then training for the people who are responsible for energy to be able to take action. So if you think of procurement within the commercial sector for how energy is used, it's bought usually by central office using buying skills, procurement skills. Then the bills are sort of certified by a manager somewhere down the line, but they don't know if that's good or fair or whatever. And then the operations people have no sight of actually the consumption in terms of the cost. So you need to draw everyone together, and you need to have stakeholders in the process and people who are empowered and given targets to effectively reduce their energy or identify ways of introducing new technologies such as solar in order to mitigate the risk. The challenge for a lot of people in this space is that there is limited understanding of a battery, how long can I use it for, what does it work? There are many competing claims, and I would hope that regulation would allow standardisation in terms of some of these reference points and the ability for modelling to take place in some sort of environment that can be certified. I think there are grey areas within all of this, and I think there will be cost considerations that will have to come in, and I suspect taxation will happen. I mean, water is an area that we're being asked increasingly to look at, and the price of water, notwithstanding the waste that's created by the water companies and the poor performance of the water companies in the environmental space, is that actually how we consume water. What happens if you had a charge that for the consumer that went up beyond a certain point? That might encourage the use of grey water storage. I believe in the UK it's very difficult to actually introduce, unlike other countries, processes for cleaning your own grey water. By that I mean sort of stuff off the guttering, not coming off the sinks, and reusing it. So in terms of looking to the future, I think we're going to see much greater accountability, but accountability with education shouldn't be a problem, and I believe that we will have to become, perhaps through the burden of price increases, tax to actually nudge that behaviour forward. At the same time, we need an openness to looking at what is used in other countries and adopting it in order to ensure that we have access to the best technology to make changes happen.
Well, excellent. I think that's a good place to end it. Matthew, thanks very much for taking the time to speak to us today regarding energy management and how it applies in some smart buildings too.
Yeah, no, happy, pleasure, Christian. If there's anything you want to follow up on, just let me know, and happy to, restate anything. But I mean, in summary, I would say that everyone has to become accountable in business for how you use your natural resources ultimately. And yes, there's the measure of the carbon reporting, but as a business with a view to sustainability and how do you maintain your efficiencies, energy is the one input that is becoming that's becoming more vague in terms of its pricing and its access. So if you've got two things, you're going to have fluctuations in pricing, and you might not be able to get power. You really want to kind of get a handle on it all, and you really want to get into control of that and have people who are educated and communicating as to how that is working for you.
Remember to subscribe to IoT Unplugged wherever you get your podcasts, and don't forget to share with anyone you think would find it as interesting or as informative as you have. IoT Unplugged. Tune in to the Internet of Things.